Let's now take a look at this review problem to find the factorization of 4,700,619. To do this, first we observe that the square root of 4,700,619 is 2,168.09. So this means that we only have to test primes up to 2,168. And if none of them work, then the number is indeed a prime number. Now, that's small consolation. Have to check a few thousand numbers out, but let's see what happens. So obviously the number is not a multiple of 2. Let's take a look at being a multiple of 3. 4 plus 7 is 11, plus 6 is 17, plus 1 is 18, plus 9 is 27. 27 is a multiple of 3. Furthermore, it's a multiple of 9. So that tells us that 4,700,619 is going to be a multiple of both 3 and 9. So let's do the division. 4,700,619. If I divide that by 9, then I have 522,291. Now let's try 3 again. If I add up the digits, I get 7, 9, 11, 20, 21. So the sum is 21, so this will be a multiple of 3, but not a multiple of 9 because 21 is not a multiple of 9. So if I take that number divided by 3, I get 174,097. And if I add up these digits, I get 8, 12, 21, 28. That's no longer a multiple of 3. Okay, so far here's what we have. We have that 4,700,619 is equal to 3 to the third, 27. We've pulled out 3 threes, times 174,097. Also, we've reduced the amount of work that we need to do considerably. Before we had to go all the way up to 2,168. Now the thing that's left is 174,097. So now I only have to try primes up to 417 to see what goes into what's left. Now that's still some work to do, but let's see what happens. So let's start trying it out and see what happens. 174,097. Now clearly this is not a multiple of 5. There's no easy trick for 7, so just divide and see what happens. And that one does work. So this one is equal to 3 to the third times 7 times 24,871. Now once again, there's no easy trick for 7, so let's try it again to see if it works again. And it does work. So 3 to the third times 7 squared times 3,553. And let's try it again to see if it works. And this one does not work, so 3,553 is not a multiple of 7. Okay, 3,553. Now this will be a multiple of 11 by the 11 trick. If I take plus 3 minus 5 plus 5 minus 3, that is 0, which is a multiple of 11. So if I actually do the division, 3,553 divided by 11, I get 323. Okay, 323 is what's left. So if I take the square root of 323, that is 17.97. So that means I only have to test the primes that are less than 17 to determine whether or not 323 is prime. So 323, the next prime number up is 13. That doesn't work. 323 divided by 17, that does work. So 3 cubed times 7 squared times 11 times 17 times 19. And I'll mention parenthetically that 323 is 324 minus 1. 324 is 18 squared. 1, of course, is 1 squared, and so by the difference of two squares, that is 18 minus 1 for 17, times 18 plus 1, which is 19. So we could have factored that by the difference of two squares if you recognize that 324 is 18 squared.